Welcome back, it's Alison here. In this video we're going to be talking about the great year and looking at how the precession of the equinoxes actually creates the great year for us. So this video is going to be part one of a two-part series on the great year and then the Age of Aquarius. So they're going to be separated into two chunks. This is the one that's coming out first and the second one will be being published later. Once you start to learn astrology, you actually go down many roads. You learn a lot of things. To start with, there's an awful lot of basic stuff that has to be learned, and then once you've got all of that under your belt, there are some other broader concepts that you can learn, such as what we're talking about here today, the great year, that will actually enhance your understanding of celestial mechanics and the astrology in general. Where does the astrology come from? How did it all begin? And what are the master cycles that are playing out that we can't even see? It's much like we know perhaps a redwood tree would go for 50 years or 100 years, but if you stand there one day and look at it, you can't see that tree growing. And it's very much the same type of things with these long astrological cycles, that we are just a blip, an absolute blip in time compared to the massive cycles that are continuing on around us. As a human, we're likely to live to be 90, maybe 100 years old, and that's the only time frame that we will see and exist on Earth. But the whole planetary, our planet, the solar system, and the whole of the universe will be flowing around on a much broader time scale, and there are some other patterns that are running through, and this is what we're going to be talking about today. So this video is really for people who are, I would call, intermediate astrologers, who want to get a bit of a grasp on what's going on and why we even care about the Great Age, what it is and how it's calculated. So enjoy. Okay, so let's get started. This is the Great Year and the Age of Aquarius, part 1. Here we're going to focus a little bit on time and space and where we fit into this massive, massive universe. It does seem to go on forever and ever. We are just terribly insignificant when you look at the broad backdrop of the universe that we live in. Now, the visible universe refers to the actual part of the universe that we can see. And with the naked eye, you can see up to a certain point. It was only when they developed telescopes could they discover the outer planets of Uranus, Neptune, and Pluto. And ultimately, as time has gone on and telescopes have got better, our ability to see further and further into the universe has expanded, but we are still limited to the visible universe, which is as much as what we can see, even though it does appear as though the universe goes on for virtually forever. Now, within our local area, we do have spiral galaxies now. The galaxy that we are in is a barred spiral galaxy, and this is an artist's impression of what it looks like. So it's a massive rotating spiral of stars and gas and energies with planets, and we are ultimately in there somewhere as well. When we look out at the night sky from Earth, as the night continues, we can see this band of stars vertically moving across the sky. You perhaps won't be able to see this if you live in a city, but certainly if you're in the country, you can see quite clearly all of this band of stars as it's rotating across the sky. So if we actually look at the Milky Way and we snap it in some fabulous light from this image, you can see here that the actual side disk of our galaxy is what you're seeing. That vertical line of stars is the edge-on view of our galaxy as we are all spinning around in a flat disk. So this clearly shows that we are part of a bigger picture that really is huge. So from our galaxy, we then move in much closer to home towards the solar system. And this is all a little bit more familiar to us. We've got the sun and we have the planets there, Mercury, Venus, Earth and Mars. And then further out, Jupiter, Saturn, Uranus and Neptune. And I see that Pluto doesn't seem to have a dot, but there is actually a line there for Pluto. We've got a couple of comets there. We're seeing some asteroids, and we can see that, although not to scale, that we are part of a little system, the solar system, which really is home for us. Now, we are going to consider that when we do look up at the night sky, we're going to talk about the difference between constellations and zodiac signs. So if you go outside and lie in a field and look up at the stars, you can see a whole load of twinkling stars up there. And of course, the ancient astrologers did this too. And humans being what they are, when we see a pattern of stars, we want to join the dots virtually join the dots and make some images there. So when the lines for the actual constellations are not shown, all you have is a mass of stars. And it's only as you are able to join the lines in a certain way that you see the images of perhaps the twins, or a bull, or a crab, or a Leo, a lion. And that's where the constellations come from. It's the human, what we are laying onto the images we see when we look up at the sky. So there are two main lines running across here. Let's have a bit of a closer look at this. So we have the ecliptic, that is the path of the sun. And then we have the celestial equator, and that is the Earth's equator extrapolated outwards into the sky, and it shows where the celestial equator is. It's in the same position as the Earth's equator. So what's happening is that the sun is passing on the plane of the ecliptic up and down, because that's how we get the seasons, which we'll look into in a moment. And so the sun's path crosses the celestial equator at certain points in the year. Now, I also want to bring your attention, or draw your attention, to these particular constellations that we are seeing here, and reading from right to left backwards. We've got Pisces, then we have Aries, Taurus, Gemini, Cancer, and Leo. This is just what we're seeing in this particular diagram. And you can clearly see that the constellation for Pisces is quite a huge connection of stars, and it's encompassing quite a large area of the sky. Then we go to Aries, which is slightly smaller because of the way the constellation is. So what we're saying here is that constellations can be random sizes, and they certainly are. Whereas signs on the tropical zodiac, which is what we use in astrology, are always 30 degrees long. So around 2,000 years ago, the plane of the ecliptic and the celestial equator actually intersected at Aries. You can see now that it's slipped a little bit further back, and we'll talk about that more in a moment. But what we are saying is that this intersection of the red and the yellow line right there where the arrow is known as the vernal equinox. This is around March 21st every year, and it's when the sun enters Aries at 0 degrees Aries. As the sun enters Aries, so we're now going to be looking a little bit more closely at the precession of the equinoxes and how it actually looks in a diagram. Over here we can see that the sun's path is in yellow, and the sun circles around the earth going north and south of the celestial equator. We can see that the Earth's equator is marked there in the little dotted line, and then the celestial equator is this plane displayed out into the sky. So what happens is that as the sun crosses the celestial equator moving north, that is the spring equinox, that is around March 21st, it then loops up high for summer in the northern hemisphere, and then it swoops back down again to the autumn equinox around September 21st and continues on to give summer to the southern hemisphere. When we look at this from the Earth, we actually see that the celestial equator is laid out. The celestial equator is the transposition, would you say, of the Earth's equator out onto the sky, and the sun crosses above it at the spring equinox at March 21st. And this is the measurement for the tropical zodiac. So it's known as the vernal equinox as well. It's the spring equinox in the northern hemisphere, and of course it is the autumn equinox in the southern hemisphere. So as the sun crosses the celestial equator going north, that is when we enter Aries. That is the beginning of the zodiac, and it's 0 degrees Aries. And in the tropical zodiac, from that point, we measure 30 degrees for each sign all the way around for the 360 degrees to put the 12 signs on it. And then, as you can see, when we get back round to the other side, we've got Capricorn, Aquarius, and Pisces finishing it off. So this is why Aries is the first sign of the zodiac, and this is why Pisces is the last sign of the zodiac. But the point is that this intersection is slowly precessing, i.e. moving backwards against the backdrop of stars, and it takes a long time and it creeps slowly backwards, but it is actually moving. So you know, going back to your school days, that the Earth's axis is tilted at around 23.5 degrees, and we see this on all globes as well. And you will be very familiar with the image there for the actual season. So these are the northern hemisphere seasons. If you look at the bottom, we have the spring equinox, that's at Aries, and then you go around to the summer solstice, that is at the height where the northern hemisphere is pointing towards the sun and gets more light and warmth. Then we have the autumn equinox, which is the opposite side to the spring equinox. And finally, the winter solstice, when the warmth and heat of the sun is no longer on the northern hemisphere, it's now on the southern hemisphere, bringing us winter. So that's around December 21st. And the summer solstice is just around June 21st. Now, this angle that the pole of the Earth is placed at 23.5 degrees is not necessarily pointing in the exact same position all the time. It is very similar to a spinning top where the North Pole is rotating very slowly and describing a circle in the sky. And we can see this type of movement by this gyroscope, which is reflection of, this is representing the Earth, and you can see clearly that North Pole is describing a circle above the Earth against the backdrop of the stars. So what this means is that as the Earth is slowly rotating on its axis over an awfully long time, that the angle of the point of the North Pole is different. So if you look at this slide now, we can see that. If you're looking on the left-hand side, that the North Pole is pointing up to the top left. If you look at the top example of the Earth, it's pointing away from us, out of the circle. The image of the Earth on the right-hand side, the pole is also pointing up to the top right, and then on the symbol for the Earth at the bottom, it's pointing towards us. So this is a different diagram showing the Earth's axial rotation over a long period of time, and it's showing that the Earth's pole is actually pointing outwards as it rotates. So as the North Pole of the Earth describes a circle in the sky, it points at different stars. And at the moment, we're recording this in the 2020, and the North Pole is pointing to Polaris, and we call that the pole star, and it always has been in our lifetime. It will remain so. But during the cycle, due to axial rotation, the North Pole will point at different stars at different times. So in our example here, we can see that it was once pointing at Thuban, which is in Alpha Draconis. There was a point when it was pointing at the star Vega, and there was a time when it was pointing at the star Alderamin. But we know Polaris as the North Star at the moment, and it will be for the rest of our lives because of the very, very slow movement that's due to axial rotation. So the red dot in the middle is perpendicular to the Earth's motion around the sun, to the actual plane, the disk of the sun, which we're traveling on. But you're bearing in mind that due to the angle of 23.5 degrees, that the North Pole is pointing at different stars over time. So we're just going to have a look at two stars here. So first is Polaris, which we know is our North Star at the moment, the pole star, and that is it right there. Now, that number there, plus 2000, that is actually the year. So in the year 2000-ish, and in the year 2020 certainly, the North Pole is pointing at Polaris. And all of these numbers in yellow are actually time frames that we are looking at, these long time frames. Another example of a different pole star was Thuban, and that was the pole star way back there at 3000 BCE, before Common Era, before Christ, which is about 5,000 years ago. The North Star, the pole star, was Thuban in a different constellation to what it is today. So slowly, as this arc of the poles of where the Earth's North Pole is pointing, it's crossing across through constellations in the sky. And before we go much further, I just want to talk about some date naming conventions which may have changed since you were a young person. So BCE means before Common Era, and it used to be known as BC, before Christ. CE refers to Common Era, which used to be AD or Anno Domini, in the year of our Lord. And an example now is that this year we are in 2020. And so you would say 2020 CE in the Common Era. It's just that we're taking away the emphasis of the Christianity to the actual dating of times. So due to the axial rotation and the fact that the Earth's North Pole points at a different place during a cycle, if you look to the left of this diagram where it says 1 CE, that was year 1 ultimately. Then moving down to the bottom of the chart, we see that this time frame was 6500 BCE. On to the right of the chart, it's 13,000 BCE, and the top of the chart we have 19,500 BCE, and then coming back again to the eastern point, 26,000 BCE is how long it takes for a full axial rotation of the North Pole. And this is actually the time frame that the Earth takes to spin and turn the North Pole, which is creating the movement and the precession of the equinoxes. So as we look at the backdrop of the stars, this is why the vernal equinox is slowly creeping along. So not only do we have axial rotation, but this is what is referred to then as the great year. And in astrology, the great year refers to the 26,000 years that it takes for the vernal equinox to precess through the whole of the zodiac. So we're working with some pretty big numbers here. So I'm going to be saying there plus minus 26,000 years, because clearly it's not exactly that time. We could be 1,000 years either way at the end, as the vernal equinox precesses through the tropical zodiac. It's that long. So being good astrologers, we take one great year and we can divide it into 12 great months. So clearly we are just giving some demarcations there against the space backdrop for 12 segments of our great year, and they are called the great months. And because we're astrologers, we then lay on the actual signs of the zodiac on them. Now this is then called either the great months or the astrological ages. And you can see at the year 1 CE, it was between Aries and Pisces, and as you go back in time, the age that we were in is actually changing. And what we are looking at the moment is around 2150 CE, the vernal equinox has moved to the cusp between Pisces and Aquarius. Rounded numbers. So we are at 2020, so what we're looking at 130 years hence, we are firmly then into Aquarius. But that's why they say we're at the dawning, right, at the age of the Aquarius. So let's have a look at what is a long time. Now, we are looking at massive time frames here, and we've decided that the great year is 26,000 years, which is a super duper long time. But if we just get it in perspective, we've been around a much longer time than that. Well, I'm just going to go through with you some approximate time summaries of life and during space and time that when we look back into history. So let's look at some approximate times in a summary. So plus minus 13 billion years ago, the Big Bang happened and the universe lit up. Then 4 billion years ago, the solar system and the Earth formed. Around plus minus 3.7 billion years ago, the first life occurred on Earth. Around 312 million years ago, the first mammal evolved. And plus minus 200,000 years ago, Homo sapiens, that's modern man and modern woman, evolved. And then finally, the time, what I have there is plus minus 11,700 years ago, the last ice age ends. So if we consider the 26,000 years, that is the length of the great year, you can see quite clearly that there have been many great years in our past, as 26,000 divides into a long, long time ago. So there we are. Thank you so much for watching. If you did enjoy this video, please do give me a thumbs up. It does help me. If you have any questions or comments about the great year, I'll be happy to answer them in the comments below. Thank you so much for watching. I'm Alison Price. I'll see you next time.